Ready to go?
Ready?
Yeah.
Okay, class, is everybody listening? Y'all having a good day?
Yeah.
So today we're going to learn. Thank you. So today we're going to be learning about metals versus non-metals. And specifically, we're going to be observing different qualities about them. So the learning outcome today, at the end of this lesson, you guys will be able to classify objects as metals or non-metals using observed physical properties. So what you guys need is a pencil, and I'm going to pass out exploration guides. You can just pass it down. Okay. Your lab roles have been pre-assigned, and you should have the roll tent in front of you. You want to just make sure that the roll tent that's in front of you is correct with what's on the board. Group 1 should be Alexis, Austin, Monique, and Taylor. And Group 2 should be Annalise, Jennifer, Tyler, and Sarah. Everybody got the right ones? Make sure you write what your role is on the top of your exploration guide. So before we get started, we need to go over a few safety measures. Sulfur can be flammable, and dust particles may be irritating to your nose or eyes or throat or skin. Silicon is also irritating to the eyes, nose, throat, and lungs, so let's just make sure we don't take anything out of the bags that are in bags. And don't put anything in your mouth. Alright, so what you guys are going to be doing today is observing each sample individually for a minute and 30 seconds, and you will have that time to complete each question for each sample.
As a group or?
As a group, yes, you can discuss. So let's go ahead and start with sample A. If you're having trouble coming up with two different characteristics, you can look at these questions as qualities to consider. So y'all can go ahead.
Silver, like in the wall. Silver, and it's like silver.
Think about the color of the object, what the material is made of, if it has a distinct texture, and think about what you think the object might be.
It lights up. Reflects. It reflects.
What do you observe when you shine light on sample?
Once you're finished with sample A, just put down your pencil.
Black.
Right, y'all can go ahead and go to sample B if you're ready. Do you notice a certain color about the sample? Is it shiny?
Shine light. It's shiny. Not shiny. What happens when you try to?
Do y'all notice anything different between these two samples?
The greatest one is great. That's
What happens when you Taylor, do you notice anything different between sample A and sample B?
What color did you say it was?
Yeah, sample A is bendy, and sample B.
That's what I was thinking.
What's the color of this copper?
I know, that's what I was
I'm afraid it's going to break if I try to.
It shines in the light.
Tyler, Did you find a different thing between these two samples, other than the fact that one is bendy and one is not?
That one's brittle, so it's not bendy.
Okay, nice. So we can go ahead and go to sample C.
Yeah.
This one's really.
Notice the similarities between sample C and sample A.
Bendy. Bendy that stays in position.
It looks speckly.
So I'm saying for the last one, it bends easily, but holds its shape.
Something shine in the dark?
Once you finish with sample C, you can go ahead and move on to sample D.
Okay, this one's shiny, but not bendy.
Is it bendy?
No.
I can put this in one. I guess I'd rather change that.
Does this sample reflect light?
Yellow.
But,
Is it hard?
I don't think it's because of the awesome.
I feel like it's a sulfur like supposed to be like a hard stone.
Alexis, does this sample reflect light?
Sample, not very.
Sample D, yes. Yes.
Yeah.
what happens when we try to manipulate the same to that?
And once you finish with sample D, go ahead and move on to sample E.
It's yellow.
Actually, look at that already.
Yellow.
Not shine.
Does it shine? Is it shiny? I mean, it's bright, but it's not shiny.
It's a pretty contrast.
Austin, does sample E resemble anything you would see in your everyday life? What it looks like?
Chalk.
Yeah?
Yeah.
It does kind of look like chalk.
Yeah.
And what qualities of chalk are similar to the sulfur?
It breaks off easily.
Is it shiny?
No. Like it's brightly colored, but it's not shiny.
Alright, once everybody's done looking at sample E, you can go ahead and put your pencils down so I know that you're ready to move on.
Okay, well, let's say we
Yeah.
manipulate.
Looks like everyone's finishing up. So now we're gonna make a teacher. So how would you guys classify these samples into two different groups? What would you classify them by? Shiny
I
and
would do
dull,
bendy and not bendy.
bendy and not bendy, okay? And so what would you name these two categories? Annalise.
I thought we did that.
What mine was,
Okay, I would do shiny and dull.
shiny and dull. That's what you would name the two categories, even though there's more than one property that's different. So the answer that we were looking for was metals or non-metal. Nope, we're doing it up here, y'all are watching.
Okay.
Alright. So we formed our T-chart in metals and non-metals, and so metals have a quality of being shiny, and they also are malleable, which means that you can bend it. So which samples would you put into that category? Ones that are shiny and bendable. So A, which one was sample A? What's the name of it? Aluminum. Okay. And which one was sample C? Copper. Anything else?
Silicon wasn't bendable though.
No. And was silicon shiny?
Silicon's shiny, but it's not bendable.
Exactly. So it has traits of both metals and non-metals. Where would y'all put sulfur?
Non-metal.
Non-metals. And what about the coal? Non-metals. And coal is made up of hydrogen, carbon, nitrogen, and oxygen. So we have all of these for coal. Okay. So here's just a picture on the board of what we just did here. Then silicon's in the middle. That's a metalloid, which y'all are going to be learning about in a future lesson, but we thought we would mention it now. So that way you just have an idea that there are things that aren't just metals or not metals.
It says the battery's low,
Oh,
so, you know, the charger's kind of funny.
okay.
Hi, it's awesome. So you guys get the whole elements? Now we're going to get into the explanation. We've already had a little taste of metals versus non-metals, but this goes a little bit more in depth. So this is a guide. Basically, you have exactly what's up here, that there are links. So keywords you're going to want to fill in. And if you don't see what's up here on your sheet, that's because it's okay. It might be extra, or it's not something that you're going to need to remember before a test. So let's first look at metals. Metals are typically solid materials that are hard, have a shiny luster, and are malleable. So these were all words that you were using during your exploration. We were saying things like shiny. What was another word for malleable?
Bendy.
Bendy. So you kind of came up with your own definition for malleable by saying bendy. We have some examples of metals, gold and calcium, which is interesting. Did anyone else think that calcium would be a metal? Where do we see calcium?
Our bones.
In our bones?
Nope.
No? You think that might be a component that makes your bones strong? It's a metal. So we have gold, calcium. It looks like we have a lot more metals than we do non-metals. And notice in the PowerPoint here, we have highlighted words. If it's highlighted, that's something that you're missing in your handout, so you're going to need to fill that one in. Yes. So shiny luster and is malleable. Malleable. Did everyone get that? Metals, so I did mention that metals are solids, usually. The misconception is that all metals are solid at room temperature, but as you can see here, mercury is actually liquid at room temperature. That's a cocktail glass of mercury. That's pretty cool, right? Let's move on to nonmetals. A nonmetal can exist as a liquid, a gas, or a solid, and lacks the characteristics of a metal. So basically, there's metals, and then there's everything else. If you look here, you have matches, that red part of a match is actually phosphorus. What are the qualities of the end of a match that might match the non-metal Alexis?
I'm sorry?
If you're looking at the tip of a match, how is that consistent with our descriptions for non-metal? Because metals are shiny and non-metals are basically the opposite.
Well, it is the tip of the match, the phosphorus, is dull and it's brittle, so when you strike it against something, it breaks and then the tip will ignite.
Yeah, exactly. And dull is a really good word to describe them. When you look at the sulfur, it doesn't reflect light. Remember, the sulfur is a non-metal, and it's dull. And then also chlorine, it exists as a gas as well. So not all non-metals are going to be things that you can touch, or things that you can necessarily see. Chlorine is yellow and misty. This is a star vocabulary word, so this is something you're going to want to focus on for this lecture. Luster is the quality, condition, or fact of shining of reflected light. That was what you were noticing when you said, this is shiny. I think one of you guys picked up the aluminum foil, and you said it was reflective. It's kind of like a mirror. That quality is called luster. And you'll notice the difference between phosphorus and beryllium. Phosphorus doesn't have that sheeny quality. So where might you put phosphorus? In the non-metal. Okay, cool. And then versus beryllium. Beryllium kind of looks like something else we saw today. Yeah, it kind of does, but it's actually metal. Another aspect of the metals, another word that I'd like you to know, is related to the bendability of the metal, or the malleability. And malleability is the physical property of metals that defines the ability to be hammered, pressed, or rolled into thin sheets without breaking. Austin, you said something about the copper. You were bending it. You kept its shape. You kept its shape. Okay. A paperclip, paperclips don't usually, they keep their shape, but if you bend them, what happens? If you keep bending them, they'll break. Okay, that's true. An aspect of malleability is that you can bend it and it will remain a pure substance, if you will. So remember how we described non-metals? Yeah, have you all seen these goods?
Yes.
This is pretty cute, but you couldn't do that with the non-metal because they're brittle, and that tension would make the non-metal break. Another application of this is kind of funny, because look at this picture of phosphorus. This is, based on the look of phosphorus, what would you classify that as? And we actually already talked about it. It's dull, and it's next to some peanut brittle.
It's a non-metal.
Yeah, non-metal. Okay. That's correct. To summarize this activity, there are a few words. Oh, yes, of course. I missed some blanks.
I read some blanks. Wait,
Any highlighted words? Did you
it was
get
the peanut
malleable?
brittle. It was the peanut brittle.
Peanut brittle?
Yeah.
Malleable.
Oh, we need brittle.
You've written malleable several times today, so I hope that you remember that word. Who likes peanut brittle? Non-metal. Okay, to summarize, we have our two classifications that we learned today. So now we can look at an object, we can decipher its properties, and we can decide if it's a metal or non-metal based off its ability to reflect light, or we also refer to that as its luster. Okay. And then what about something that was bendable, bendy? Malleable. There. And then something that's not malleable is the opposite of that. So dull or not malleable. Okay, so now you can actually use your lecture as your study guide. And next time we'll be talking about metal